Hello and welcome to our discussion of predicting the products of decomposition reactions. So to this point, we have been able to predict the products of single and double replacement reactions, and in those situations, they don't always occur. When I present you with some decomposition reactions, you are going to assume that it will occur, and our job is to find the right reference rules to identify what will happen. So the decomp clouds or the decomp rules, depending on how they're presented on your worksheet, I have them listed more as a set of rules like what you're going to see on the next page. You will read them based on the reactant, because it's decomposition, so there's only one, and then you will apply the rule to identify what is going to be produced. So when we take a look, there are 5 different categories of reactants that you could have. So a binary compound is an element or a compound with 2 elements only. At that point, all you can really do is separate the elements. So if there's only 2 things in the compound, those are pretty easy because all I do is split them apart and write them in their correct form for the separate elements. The remaining 4 are going to be a little bit more complex because with more than 2 elements, we need to know exactly where the break occurs. So in order to identify what type of reactant you have, you're simply going to match the name to what is in the compound. So an oxyacid would be one of those acids that has H first and then a polyatomic ion bonded to it. So your sulfuric acids, your chloric acids, anything without the hydro in it would fall in that category. What that will break apart into is a non-metallic oxide and water. So pretty much all you do is you remove water from the acid, and the leftover is going to be the bonding between the oxygen and the other non-metal substance. So you pretty much take the polyatomic and the H's and take off a water molecule. The metallic carbonate means you have some kind of metal, any metal, bonded to the ion carbonate. In this case, it will break apart into carbon dioxide and the metallic oxide. So whatever compound that metal would make when it bonds with oxygen. Metallic chlorate is kind of the weird outlier. Notice that 3 of the 5 create a something oxide. When you're dealing with the chlorate, that's kind of the odd one out. That's going to produce a chloride compound. But then oxygen is what is left over. Excuse me. Also notice that 2 of the products involve water. So you're going to see a couple different times where water shows up. So the easiest way to do this is in the context of examples. So we're going to take a look at the examples below, classify them using the correct example rule, and then write out the products and balance the equation. So here we have our calcium hydroxide. Calcium bonded to hydroxide would be a metallic hydroxide right here. So it tells us we're going to break apart into the metallic oxide, and water will be the other product. So the water's easy. Let's write that down right away. Then I have to come up with the combination between calcium and oxygen. Well, since calcium is a 2+ and oxygen is a 2-, that means CaO would be my formula. So now that I have the correct formulas, I'm going to go check my balancing. I have 1 calcium on the left and 1 on the right. I have 2 oxygens on the left because of the parentheses, and then 1, 2 on the right. And then my hydrogen, I have 2 because of the parentheses on the left, and then 2 in the water molecule on the right. So this reaction is balanced. You will notice that many decomposition reactions, not all, but many of them will be balanced by the time you have the formulas correctly written. So let's look at another one. We've got, we're going to skip KOH because it's the same type of compound. H2O. There are two elements, so that's a binary. Tells us we're going to separate the elements. So H and O are both Hofbrinkel elements, which means I need H2 plus O2. Then because of the O2, I need two waters on the left, which then means I need two hydrogen molecules on the right. So again, pretty straightforward. Let's do one more. I'm going to pause here quick and add in another compound. So I just want to add in another one of the more complex ones. So here we have magnesium chlorate, which means that I have a metallic chlorate, and it tells us we move into a metallic chloride and oxygen. So let's get the oxygen down. That one's pretty straightforward. So magnesium is a +2, and chlorine is a -1. So that tells us we are going to need an MgCl2 compound. Now what you may have noticed is that there's a little bit of complexity here because I have MgCl2, but I've got the 3 O's and that going on over here. So I have technically 2 chlorines, but I have 6 oxygen, and here that means all I have to change is the oxygen. All of the rest of the elements balance out. So the biggest trick is just making sure that you do the right split depending on the compound that you have. I'm going to have us try one more of our oxy acids because that one can be a little tricky. So last one is an oxy acid. Let's look back up and see what we have here. So with an oxy acid, I'm going to bring it to a non-metallic oxide in water. So what I'm going to do is to simply take off the water that's in there, and whatever's left over will be the non-metallic oxide. So in my compound here, if I take away 2 H's and 1 O, that's my water. So there would be no H left over, and then if I reduce the SO4 by 1 oxygen, that results in SO3. So in this case, no balancing needed because I simply took away the water that was present and everything matches up. So you will be given the rules above. These will be provided to you. Your job is to simply follow the rules once you've identified what type of reactant you have. At this point, you should now continue through the packet and do page 2 of the Predicting Products packet. And you are now also, with a little bit of practice on combustion, ready to start the mixed practice on the back.